In this lesson of 11.3, we're going to be looking at areas of polygons and composite figures. We're first going to look at areas of rhombuses and kites, and then we'll be able to look at various regular polygons, ones that have more than just those four sides. And then we'll combine that all in order to break up shapes, odd shapes, into figures that we can find the area of and be able to add them together. And so the first thing we look at is rhombuses and kites, or rhombi and kites. For them, we're going to be looking at their diagonals, and so that we have the formula that we're going to use every time. And so if we look at the diagonals, remember diagonals just connect those opposite vertices. Then we take the half of both the diagonals multiplied together. And so the area is written right here, but if we want to just write it out, the area is equal to 1/2 d1 times d2. And it doesn't matter which one you plug in for D1 or D2, you just multiply them, divide by 2, and that's going to be your area. So in this first example, we're going to look at area of both a rhombus and a kite. So the first one, A, this is a rhombus. Remember, a rhombus says all four sides are equal. It just doesn't have the 90-degree angle. It's like a square. It's like kind of tilted over. And so we want to do the formula we just learned. So area equals 1/2 d1 times d2, and it doesn't matter which one, again, that I use, like this one can be my d1, this one my d2, and so I'm just going to plug them in. So I have 1/2 times 6 and times 8, and so when I do that, 6 times 8 divided by 2, that's going to give me 24. And then my label on this is meters. And remember, this is area, and area is always meters squared or anything squared. So that would be our answer for this first one. In B, we have a kite. We use the same formula for a rhombus or a kite. So we do 1/2 d1 times d2. And so when we plug that in, we have 1/2 times 7 and times 10. When you multiply all that out, you get 35, and so our label again, now it's centimeters, and then put our square on there, centimeters squared. So then we're going to be looking at our regular polygons. Regular polygons, okay, remember regular means all the sides and all the angles are equal. And then we're going to have various polygons, whether they have 7 sides, 8 sides, 10 sides, however many. But the main parts of it, we're going to have the same formula for all of them. But the main part that we need to know is we need to be able to look at the radius, and so the radius would be going out to that far point. So when we put it in a circle, like you can see as a label here in red, they have the radius of PN or the radius of PM would have worked either side. And then we also have what we call the apothem. And so the apothem is going to be when we go straight out to that side. So it's not the radius. The radius goes out to one of the vertices. Okay, so from the center of our polygon out to the vertice, the apothem is going to be the shortest distance from the center out to that middle. And so when we have that apothem, it's going to split that side, right there, that side in half as well. And so as we look at this first one, we're just going to kind of start working with apothems and radius on these polygons. So here we have a pentagon. It's inscribed inside a circle. And so first we have the radius that's in red. And so I'm going to go ahead and draw all the radius out to those vertices, because our first question is going to ask us for AFB. And so AFB is this angle that's right here. Notice that we have, once we draw that radius out, okay, all these will be equally spaced because it's a pentagon. It's a regular polygon that has all the same length sides. And so it's going to divide the circle up into 5 equal parts. And so if we're talking about that angle, that means that's the same angle that's on all of these parts right here. Okay, it's going to be the same piece on every single one. And so when we go all the way around in a circle, think about go all the way around, that's 360 degrees. And so we just divided it into 5 parts, basically. So in order to solve for this first one, if we want that angle of AFB, we would just do 360 divided by 5. And so when we do that, 360 divided by 5, we're going to get 72 degrees. And so our first answer here is going to be 72 degrees. The next one asks for AFG. AFG is the smaller portion here, okay, because it's going to go along the radius and the apothem. Okay, and so when we have that apothem there, it cuts that side in half, that angle there in half, that triangle. And so it would just be half of AFB. So if I want to find this one, I would just do 72 divided by 2, in which I would get 36 degrees. Okay, or you could also think about this if we drew all the radius and apothems all the way around, we could look at how many times we split up our circle then. And so that would end up being 10 times, and so 360 divided by 10 would also give us 36. Okay, and then in our next one, it wants GAF. And so GAF is going to be this angle right here. And so we know that AFG was 36, right? Here was the 36, and I kind of write it in there. And so now we just have a right triangle, and so all I'm going to do is I'm going to do 180 minus my 36 and minus my 90-degree angle, and that's going to leave me the leftover there of GAF, because that's just solving a right triangle now. And so when we do that, we end up getting 54 for that last one. And so then moving on to try to actually find the area of these polygons, you can look at the top here where it's going to show you how they actually derive the formula. And so the area of a regular polygon is we do A equals 1/2. The little a stands for apothem. Okay, so if you notice here it has apothem A times the perimeter P. Okay, it also clarifies here that you could also find this by doing, if you don't know the perimeter or you don't want to think about adding up all the sides, since it's a regular polygon, that would be whatever the number of sides that we have times the length of that side would also be the perimeter. Okay, so you're going to use this formula, A equals 1/2 apothem times perimeter. So as we look at example 3, we have a regular nonagon inscribed in a circle with a radius of 4. And so a nonagon is 9 sides, okay, or you could have counted them. And so we need to be able to find the area. So we want area is equal to 1/2 the apothem times the perimeter. Okay, but in order to find the perimeter, we need to know what that side length is, and right now we're not given it in the picture. So if we first think about this triangle, and I'm just going to redraw those triangles here. Okay, so we have the radius on the outsides are 4. This would be our points L, K, and J. I'm just redrawing it. This is our apothem, and this whole thing would be our side. If I want to find these sides, I can think about finding the angle first. And so this angle in here, we can find it by, again, like we did in the last problem, dividing this up into all equal triangles. And so if I were to divide them all up by the radius and the apothem to every single side, it would divide my triangle up into 18 triangles. Or I mean my nonagon up into 18 triangles, right? If I counted all these, I'm going to split it up into 18. So first, to find that angle, I can do 360 divided by 18. And so when we solve that, it's going to give us 20. So I'm going to put in here, this is 20 degrees. And so now, if you recognize, now we have this right triangle, we can use trig functions that we've been doing. Okay, so trig, in this case, we have the right triangle. So if that's my reference angle, I need to think about my opposite, my hypotenuse, and my adjacent. And so this side will be my opposite. Here, my 4 is my hypotenuse, and my apothem here would be my adjacent. I need to get my apothem, and I need to get my side length, because I need to find my perimeter. So I'm going to have to use both one that uses opposite and one that uses adjacent. So first I'm going to think about the side. I'm going to do my opposite, and so I'm going to use opposite and hypotenuse, which would be my sine function. So sine of 20 would equal opposite over hypotenuse. So I'm just going to term this here as x. I'm going to do x over 4. In order to solve, I multiply by the denominator, so I multiply by 4. And so when I do that, 4 sine of 20 gives me 1.37. I'm just going to do 2 decimals. So I'm going to write that in here now. This is 1.37. I also need to get my apothem there, so for my apothem, I'm going to use cosine. So if I do cosine of 20 would equal my adjacent, my apothem of A, over my hypotenuse 4. So if I multiply by 4 here, I'm going to do 4 cosine of 20. And so when I work that out, I get 3.76. And so the last thing you think about for perimeter, I would need to double for this side, right? This is just 1/2 of it here, like this 1.37 only does this part. So if I multiply that by 2, I get the whole side length there of 2.74. So my S is 2.74. And so my perimeter would be every single one of these sides over here would be 2.74, right? All the way around. And so I would have it 9 times. And so either I can add it all up 9 times, or it's the same thing as multiplying it by 9. So when I want my perimeter here of this shape would equal 24.66. And so now to find my area, I'm just going to plug everything in. So I have my area is equal to 1/2 apothem. My apothem was the 3.76 times perimeter, which is my 24.66. And so when I multiply that out, I get an area of 46.36. So my area for this shape is 46.36 units squared, because it didn't give us a specific unit, so I would just say units squared. Okay, these problems are just several steps. If you're getting lost on a step somewhere, just come and ask for clarification, and I'll try to clear it up, so that way we can get you going. It's just several steps, breaking it down in order to solve to your final place that we're trying to find, the area in this case. In this next example, we're looking at covering a table with ceramic tiles. And so it gives us an octagon. It has 15-inch sides and a radius of 19.6 inches, and asks us what is the area you're covering. Okay, so we're still using the same formula. Area equals 1/2 apothem times perimeter. The perimeter, we already have the side length, so once again we would just have 15 all the way around here. Okay, and so that would be, we have 15 8 times. And so when we do 15 times 8, that's going to give us the perimeter. And so when we do that, perimeter, like I said, it's 15 times 8, and it would equal 120. But we need to find the apothem. So if we look at this picture here, we have the radius of 19.6, but we need to find the apothem that would go straight here. Okay, so if we want to find the apothem, that side length would be 1/2 of 15, and so that would be 7.5 here. And so you could do Pythagorean's theorem here. If you wanted to solve for the angle, you could end up using trig. I'm just going to do Pythagorean's theorem. So I have my a squared plus b squared equals c squared. In this case, my c is across from the right angle, so that's the 19.6. My a I'm going to leave as my a to stand for the apothem. And so my b is at 7.5. So I'm going to square this out. So my 19.6 squared is 384.16. My 7.5 squared is 56.25. And then I still have a squared here. So I would subtract my 56 from both sides. And so that would end up giving me that a squared is equal to 327.91. And to get a by itself, I would take the square root. And so a is equal to 18.12. And so that a is my apothem. So that now I can plug in everything for my formula. So area is equal to 1/2 the apothem, my 18.12. times the perimeter that we found of 120. And so when we do that, we multiply it out. My area, in this case, is 1,087.2. This was in inches, so it's in inches squared. This last example, we're looking at composite figures. Composite figures are just when we're combining, or we have an odd shape and we can break it down into figures that we can actually find the area of, and then we add all those areas up together. And so for A, for this area, we need to be able to add first the area of a regular hexagon. Okay, because we have all the same angles, we have all the same sides, so that means this will be the area of a regular hexagon plus the area of a trapezoid. Okay, that other shape there on the side, that's a trapezoid. And so when we do area of a regular hexagon, that's the one that we've been doing, so that's 1/2 apothem times perimeter. Areas of trapezoids are 1/2 base 1 plus base 2 times the height. Okay, and the formulas like that, these two formulas, they're on your formula charts. Find the area of a trapezoid, find the area of a regular polygon. And so we need to fill in our parts. We may need to solve for something first, like in this hexagon, we don't have the apothem yet, but we do have this triangle that we can pull out, and we can actually solve that triangle instead, because we have 1.6 here, we have 0.8, and so for the apothem, we can do Pythagorean theorem again, like we did on the last problem. And so Pythagorean theorem, we're going to have our a squared plus b squared equals c squared, and so when you work that out, okay, and we should know how to do this by now, okay, but a squared plus b squared equals our c squared. That means we're going to have the apothem squared plus b would be our 0.8 squared, and c would be our 1.6 squared. And so once you solve that, you're going to end up getting that the apothem is approximately 1.39, okay? This is just Pythagorean theorem. We should be able to solve that on our own by now. And so I can plug that part in. I have 1/2 times 1.39 times the perimeter. Perimeter is going to be that 0.8 times, to get it all the way around, I'd have that 0.8 here, 0.8 again. Okay, so every single time is going to be 0.8 times plus itself, or times 2. And so that means that the actual side length is 1.6. The hexagon, I would have that 6 times, so 1.6 times 6 means that the perimeter is 9.6. And then we're just filling in our hexagon as well. So then we have 1/2. The bases are the top and the bottom, so that's the 1 and the 2. And then our height is the 1.5. So then you would just put this in your calculator. You can do it separately. You can type it all out as one. Just make sure you keep your parentheses and do them all in the correct order. And so when you put that in, you should get approximately 8.9 as your area. And so this was in inches, so it would be in inches squared. And so I'm going to erase some of this and rewrite that. So when you multiply all this out, you're going to get approximately 8.9 inches squared. Okay, so that's our answer for that first one. Okay, so I'm going to erase this to go to the next one. Our next one, we're going to need to break it down in a few more shapes. First, we have a triangle on one side, so we could do 1/2 base times height, right? So we have area, so we would need to do the area of a triangle. Okay, 1/2 base times height. And then we're going to have to do area of another triangle here. Okay, or we could just do area of a sector. Notice that this is rounded on the end. We could try to find each part. So we're just going to do area of a sector, which we learned in this last couple lessons. So now we need to plug these in. So the total area of our composite shape would be area of the triangle, so 1/2 base times height. Area of a sector is the measure of the angle, okay, over 360 times pi times r squared. Okay, so we plug in our area for our triangle, 1/2 base times height. Our base length is 7 Our height is 4. The measure of our angle for our sector is 60, so I put that on top, over 360. Then we have pi, and then our r is that 7 squared. Okay, because if we completed this, okay, think about this sector, if we completed it out to be a circle, that would be like our radius there. Okay, so now we would just multiply this out again in your calculator, and so when you do that, you're going to get approximately 39.66, and this is in centimeters, so it would be centimeters squared. Okay. The very last one is just doing a kite first, and so we just did that in this lesson. So you would do area of a kite plus area of a parallelogram. Parallelogram is just base times height. So that one's pretty easy to set up, so we're not going to do that in the video for the sake of time. But if you need help setting it up, just please come and ask.